So I'd like to introduce Philip Smith, who will be presenting BGP techniques for service providers. Philip is a senior network engineer at the Network Startup Resource Center and has traveled today from Brisbane, Australia to join us today. Philip is no stranger to NANOG. This is actually his 24th time presenting at NANOG. Philip's first talk was a similar title, BGP for Internet Service Providers, back at NANOG 92 in Scottsdale, Arizona, back in May 2001. So without further ado, I'd like to welcome Philip to the stage for the presentation today.
Thank you very much. So I hope all this is working. I should have brought sunglasses. I didn't realize it was going to be quite so bright as this up on the stage with the lights, but anyway. So as the AV folks were saying during the break, I've actually got quite a lot of content. I did this, well, some of this tutorial in Seattle a year ago. So what I was planning to do here at the PC's suggestion was to probably go a little bit quickly through the first third of it or so, so we can try and get to some of the more interesting stuff here. It's actually kind of funny because I hadn't actually counted how many times I've been to NANOG, and it was only when Valerie was saying, "Oh no, if you can give us the exact time." And I was looking at that very first tutorial I did back 2000 and 2001 in Scottsdale, and somehow I managed to fit probably all the content and what was it, 180 minutes or something. And when I look at what I have now, okay, it's 120 minutes now, but when I look at what I covered in that slide deck versus what BGP has become now and all the other best practices and so on that we've learned in the last 23 years, things have moved on really quite a long way. So I'll spend a bit of time looking at some of the basics, but not too much time. So I apologize for that if you wanted to come for a 101. I'll still go through it. I'm not going to say I'm going to jump the first 40 or 50 slides or so, but I'll go through relatively quickly. So I can try and focus on some a bit more of the deployment things. But then saying that, there are a lot of things I've not included in this tutorial, again, just for the sake of time. I could probably spend a full day going through all the best practices things. So, and as I said in Seattle, please give the feedback to the PC if you feel that we could spend a worthwhile full day trying to go through some of, from the beginning all the way through to current best practices, and a lot of deployment scenarios, multi-homing, traffic engineering, and you name it. We could probably spend a full day covering that. Not sure if I want to talk for a full day, but there's certainly that potential there. Anyways, so the presentation slides and these ones here, they'll go on the NANOG website. They go on my own archive as well. So I don't know when they'll appear on the NANOG site. If not already there, I haven't checked, but please have a look-see. Also, we have recorded, one of the things we at NSRC did before and during the pandemic was when we're all locked down and couldn't really do very much, we recorded a lot of these talks. I mean, not just the BGP presentation, but there's a whole heap of other things as well. So if 120 minutes of me going on and on and on is too much for you, you can actually go back and have a look at some of these presentations in short snippets, maybe 2, 3, 5, 10 minutes max. If it's a particular thing, maybe I went through too fast, or maybe spent too much time on it or whatever, you can actually go and have a look-see for those. Right, so I think I need to stand here. What I'm going to start with, we'll just have a look at the hierarchy of the routing protocols first. And the first piece I'm not really going to spend any time, I'm not going to spend any time at all looking at, is how the routers find each other inside a network. So that is in the realms of using ISIs or OSPF. Those are the two that are commonly used today. Not going to spend time doing that because, well, it's should be relatively straightforward. The interior routing protocol, we've called that IGP for a long time historically. What I'm going to spend more time looking at is how the routers find each other within globally reachable destinations. So we're going to be looking at BGP. iBGP is what's used inside the network. So we'll have a quick look at that. And how do the routers across the networks that make up the internet share this routing information with each other? So that's eBGP. I mean, the whole thing is still the Border Gateway Protocol, but we'll look a little bit at iBGP, and we'll look, of course, most of the time is in eBGP. Now, the basics is what I want to go through quickly. If you give me for doing that, I want to go through it quite quickly. I'm not going to miss it out, whoops, but I'll go through it relatively quickly. And we'll look more at scaling, using the communities. The communities are an incredibly important part. I've been saying probably for 20 years, it's really worth the effort understanding how BGP communities work, because without those, it's going to be really hard to implement a lot of policies. And then finally, the deploying BGP in a service provider network. I mean, that one is, well, how long is a piece of string, really? Because there are so many different circumstances and situations. So we'll look at some of the important bits. Again, more focusing on the best practices. All right. So the first piece, just looking at some of the basics. So BGP stands for Border Gateway Protocol, as I'm sure you know. RFC 4271 is the IETF documentation describing the standard. Most vendors these days have implemented something approximating to 4271. It's not, nobody's ever followed it exactly. There've been lots of modifications and tweaks just to try and make the day-to-day network work, but 4271 is the reference specification. We've got 4276 and 77, which are implementation report and operational experiences. I mean, these days, probably not really so relevant. It's part of the IETF system needing just, well, how did you get on coding the thing? And how did you get on actually using it in day-to-day? Another important piece of BGP is the autonomous system, and that's used to uniquely identify networks with a common routing policy. I suppose day-to-day understanding is an autonomous system maps onto the organization, but actually autonomous system describes routing policy of one particular thing. Organization can have multiple autonomous systems because they could have lots of different routing policies for different parts of the network. You know, typically if you've got an access network, you have a transit network, you may run a data center, you may, part of your company may be a mobile operator. All of these will have different routing policies, and they will typically use different autonomous system numbers to achieve that. Okay, so the AS is there, group of routers. The AS itself, 32-bit integer these days. Back when I started doing this, it was 16-bit integer. The range was expanded probably around about 2008, started in common use. So 32-bit integer range, that gives us up to 4 billion autonomous system numbers. Probably enough for one for every 2 people on the planet, so that's probably enough. Probably not going to run out of those anytime soon. I've got a table there of the range. Yeah, the screen is a little bit small, but there's ranges showing those with special use. You can look this up in the IANA pages as well. But you know, typically today we're using range 1 to 64495, and then we've got 131.072 up to 458.751 is what we see in the global routing table today. Everything outside those ranges are either private, so never should appear on the internet, we'll come to this later, or for documentation, or just being IANA reserved, so also should not appear on the global table. The basics, BGP runs TCP port 179. We've got the concept of internal, external, as I mentioned, supports v4, v6, and well, whatever else you want to try and support. That's the way it's all going. Concept of the demarcation zone, which is the bit of network really between the autonomous systems. So in this picture here, I've got a link between router A and C, point-to-point link, or the other one between B, D, and E, like a three-way connection. So it could be an internet exchange point as a typical example, common shared media. General operation, learning paths via internal speakers, so inside the network, or from outside locations, other autonomous systems. Picks the best path. There's an algorithm to do that. Best path is sent to external neighbors. And then the way you implement policy in BGP is modifying the best path selection. You influence it to get the outcome that you wanted. We'll look at that. Multi-protocol extensions. So for example, supporting IPv6, that's the common one. But people seem to like adding all kinds of things to BGP. So we've got MPLS, as some of you know. We've got multicast extensions, etc., etc., etc. BGP has really become the workhorse for the global internet. V6 in particular, RFC 2545 describes that extension there. So you don't need to worry about the numbers as far as any implementation go, because your vendor takes care of how you display the address family. We'll show you that in a minute. There's one RIB per protocol. In a multi-protocol setup, you've got a V4 RIB for V4, you've got a V6 RIB for V6. We don't really mix them all together. Each protocol can have its own policy. So a V4, you could have a certain set of policies for V4, you could have another set of policies for V6. And, well, the general advice is always to try and keep the policies symmetric. Some of you are probably listening to Jeff this morning talking about how successful V6 has been, or otherwise. One of the early internet experiences I certainly had with deploying V6, I mean, I was starting 1996, 97 doing some of this, was that people had different policies for V4 and V6, and that really violates the principle of least surprise. You really want things to behave the same way. What else can I quickly skip through? So I've talked about iBGP, eBGP. eBGP, between different autonomous systems. iBGP is what runs inside your own autonomous system. Lets you carry your subnets, your address space, your customer prefix, and whatever else. Full table if you really are brave enough to want to do that. Whereas eBGP is where you're going to see the global internet and where you implement your routing policies. I suppose a picture could look like this. I know, I just see it as lots of little bins, and eBGP is the thing that scoops prefixes from one bin to the next one. It's a simple way of seeing how it functions. Okay, what do I want to say here? Not a lot really, eBGP. It's just showing the picture of how eBGP functions. The only fun thing, again with best practices, that demarcation link between the two autonomous systems, either direct physical connection, or if you have to use a static route. I see in a lot of places around the world, and all the times I've done, people trying to run interior protocols between those two external ASs. You really want to try and avoid that. Interior protocol is, well, interior means inside, which is inside your AS. And, the cases over the years of leaking of OSPF between different ASs, yeah, I've had plenty of those stories. So eBGP speakers need to be directly connected. That's very important. Whereas internal BGP, you don't care. You've got an interior protocol, OSPF or ISIS. It's commonly used inside an autonomous system. Cisco has their own proprietary protocol, and some people used to use one called Rest in Peace. Please don't use that. It's OSPF, ISIS, and everything else, just forget it. For running for the IGP inside your autonomous system. So iBGP, again, if you look at the specification, has to be fully meshed. This doesn't scale. And so, as we'll see in a little bit, the way we scale inside the BGP inside the backbone is to use something called a route reflector. And the reason for being fully meshed by specification is that iBGP will only take prefixes from outside the autonomous system or locally originated. It doesn't pass prefixes it learns from other routers inside the AS. It's not like OSPF or ISIS. It only takes what it hears from outside or what is originated directly in the router itself. Otherwise, I mean, this thing just wouldn't scale at all. I'll jump the pictures. This one, commonly we run iBGP between loopback interfaces on the device. You can run it between physical interfaces as well. The issue is, if you lose a physical interface and you have an alternative path between the two routers, you lose the iBGP session. And if you lose the iBGP session, you're really breaking your backbone. So the proper design, build it between loopback interfaces. And I've had networks over the years where they said, but I've only got two routers, that's all we need. I'll just do it in the point-to-point. It's fine until you add the third one, and you've got an alternative path. You lose the direct link, and you lose your iBGP session. So build it between the loopbacks. Your OSPF or ISIS will always find a way to get between the routers. The show commands, well, pick your vendor, pick your, you wish, Cisco, Juniper, the folks who copy that CLI style, they've got the ways of showing the status, the next hop, and a whole heap of other things. So, just giving examples. Skip through all those. BGP attributes. Now, BGP will carry the prefixes, but a lot of things about these prefixes we want to carry as well. The most important one we want to carry is which autonomous system the prefix originated from. And then, well, how did that prefix get here? Who did it pass through? So that's probably one of the most important attributes, at least to have the protocol function, and a whole lot of other ones. And it's kind of, as we've gone through the years, little bits and pieces have been added to BGP as well. I started my internet service provider days in 1993, and that was still BGP version 3. It was all classful. I remember the switch over in 1994, early 1994, to classless BGP version 4. That was all kind of fun, and it all just worked. But from those years, 94, I think it was 94 through to about 99, was really, I saw as the heyday with all these things were added. It was not just, the napkins with the early protocol design, but it was also a lot of, not IETF meetings, but the side meetings, the likes of NANOG and RIPE meetings and IETF itself. What about this? What about these ideas? So were quite a few other characteristics and so on added to the protocol in that time. Anyway, let's quickly skip through the attributes. These are the main ones we'll have a look at, but again, for the sake of time, we'll jump through these. They should be relatively familiar if you're using BGP on a daily basis. AS path is super important. As I was saying before, it shows you the origin of the prefix, so who originated into the routing system, and then where it's been to get to you. So it's a bit like your baggage tag. For those of you who fly far too much, it's a bit like your baggage tag showing you the airports that the airline claims your suitcase is going to go through. Hopefully it matches your one, what your boarding passes say. But that lets you, as the one who's learned the prefix, know where which autonomous systems the prefix has jumped through. So that's very important, pardon me, for loop detection, and also for applying policy, because you can then do policies based on, I don't like that AS, I'm not going to send my traffic that way, I'm going to send it another direction. So that's very, very important. So every prefix you learn will have a list of autonomous systems attached to it saying this is how that prefix got to me. The loop detection, something like this. The internet's not just a long string. It's very dense, richly meshed infrastructure. So of course there are going to be multiple paths to get to multiple places. And what you'd want to avoid is a BGP announcement starting one place, traveling through the internet, finding its way back to you, and you're going, ooh, that's exciting. This is a brand new prefix. I wonder what I should do with it, when it's already in your BGP table. So you want to be able to avoid these BGP announcement loops. Otherwise, it'll go explode very, very quickly. The next hop, is, as the name suggests, the IP address of the next device along the path. So in other words, it's where you have learned the prefix from, right? The address of the router in the next autonomous system where you've learned the prefix from. So in this picture, router B there has learned the prefix from router A. Router A has the address 164.1.1, so that's the next hop. It doesn't care what the link between AS64500 and 64501 is. Yes, there's a next hop value there, but it's not relevant to router B. So every time you learn a prefix from the neighboring router, you will rewrite the next hop to be where you learned it from. So that sounds nice, but there's a problem, because it means you've got to carry all these next hop addresses in your interior protocol, so you can actually find how to get to the external next hop. So another best practice on the next slide is you reset the next hop to be on the local router, your own router that learned the prefix, rather than having to carry all these external next hops. And that helps scale your IGP. I mean, it's some of my early years, I spent 13 years working at Cisco doing this type of thing, actually, not selling products or equipment or anything, that didn't matter. It was doing the tuition of how routing protocols worked, how the internet worked, building ISPs and so forth. And there were so many places we found with, ISPs carrying vast amount of external prefixes in their IGP. And it's like, oh yeah, OSPF can't carry 20,000 prefixes. Well, yeah, it's not designed to do that. Wow, Cisco should make faster routers. Well, OSPF is not designed to carry 20,000 prefixes. So it's trying to get some of these design best practices in place. So next hop best practice, Cisco command is that next hop self, Juniper, the next hop self concept as well. So that's really is very much a best practice what to do. That way you don't have to carry the externals around in your IGP because, of course, design goal, minimize the size of what you carry in ISIS OSPF. Now, for a lot of the small networks and a lot of the regions of the world I visit, they go, yeah, well, but I've only got 50 routers. Yes, I say, well, but there's some networks worldwide. I've got 2,000, 3,000, 5,000, 10,000. How do you think they're going to scale? Oh, we'll never get that big. But it's amazing how many places end up getting that big, even though they never planned for it. So you design it, how you're going to scale it in the long term in the future. Don't just say, oh, yeah, I'll just do this now, and maybe next year I'll improve on it. It's like anything temporary that you do. If you do something temporary now, it becomes production, and a year later you go, oh, why did I do this? So do it right as you intend from the start. iBGP next hop. This is just pointing out that when you introduce a prefix into your interior iBGP, the next hop addresses the IP address of the loopback because you're running iBGP between loopbacks. That's perfectly fine because OSPF or ISIS is the routing protocol that's getting you to that router. I mean, that picture there, what are the red lines? Are they the iBGP sessions? Is it the physical network? Doesn't matter, don't care. There could be lots of other devices in the middle there. The point is, ISIS or OSPF will find out how to get from router B to router D. The next hop address, as far as router D is concerned, points to, well, router B in the example of 164.1/24 prefix. So that way, you don't have to care in iBGP what your internal infrastructure looks like. You've got the recursive route lookup, so OSPF or ISIS can get you where you need to go. Third-party next hop. This is particularly interesting to internet exchange points. And I'm not going to tell a story at the expense of Cisco, but I will. So here we've got the situation, AS64500 is peering with 64501. Okay, fair enough. It's a bilateral peering. Router C originating a prefix or whatever, or sending a prefix to router B. 64501 peering with 64502, and 64502 sees 64500's prefix. So 168.1/24 is being learned from AS64500. They don't have direct peering session. Now, if you follow the rules of next hop, well, router B's learning that prefix from 164.1.3. Prefix gets sent to router A, but it first checks the next hop in the attribute that's sent, and sees that the existing next hop is on the same subnet as where it learned the prefix from. Now remember in the eBGP chain I showed you a few slides ago, I said, oh, it doesn't care what happened between the two remote ASs. No, because the subnet was on a different address range. Whereas here, it's a common shared subnet. So this is particularly useful internet exchange points because even though the green line there shows the BGP announcement path, the actual traffic path from A to C will be direct. Right? So this is an exchange point. Traffic from router A to get to 64500 goes direct to router C. It does not go through router B. And so router B is what we see in exchange point today, something called the route server. Right? Exchange point, your traffic does not go through the route server. And it was my big argument with a product manager of the day saying, oh, the route server needs to be a very, very big router. It's like, no, it could be on a tiny little Cisco 800. Because all it needs to do is BGP. It doesn't need to do anything else. And you see route servers today at most exchange points are not humongous devices. They're usually like tiny little boxes. As long as they can run the BGP protocol and carry the prefixes and the sessions, that's all that's actually needed. So the important thing out of this is route server does not carry the traffic of the exchange point. Rightio, moving on quickly. Origin I won't bother about. It's pretty much historical. Some people use it for policy, but I'll skate through that. The aggregator, historical, forget it. Local preference is important. Local preference is the most powerful of the BGP attributes. It lets you steer traffic out of your network. Right? We have a situation like this. Human can look at it and say, yeah, today I feel like going through 64502. Tomorrow, I'll go through 64503. You don't have that intelligence in the routers, and please don't even start me on AI or machine learning. You don't have that intelligence in routers. You need to determine where things are going to go, right? So you can use local preference. So here I've put local preference 800 on the right-hand side and 500 on the left-hand side. We now have two entries in the BGP table on AS64504. Highest preference is through the right-hand side, 64503. That's the way traffic goes. So this is the most powerful attribute. It will let you override everything else. Right? So no matter what everybody else does with the prefixes, that prefix, multiple paths, highest local preference will win. Right? So traffic between 64504 and 64501 will follow the red arrow on the screen now. Right? So that's local preference. You can override everything else. Non-transitive attribute, because it's only used locally. It's optional. You don't have to set it. By most vendors, the default value is 100 if you don't set anything. Multi-exit discriminator. I mean, I don't know. For years and years, I've kept saying, yeah, I probably should drop this because people don't really use it because they override it with local pref. And we'll look at this a bit later on. But I still include it because there's still people who are using it, especially when they've got, say, a couple of routers on usually a peering LAN at an exchange point. So here you can tell a neighboring AS which incoming path to use. So in this example, I've made an announcement, one prefix, one path is a MED 2000, other one's a path, MED 1000. 64502, the remote AS sees two paths, one with MED 2000, the other one with 1000. And just to confuse, lowest MED wins. It kind of maps onto the metric that we know about in IGP. Lowest metric in OSPF ISIS wins. In fact, some vendors still call it metric in BGP, even though the official name is multi-exit discriminator. I don't know. I prefer metric because I guess I've been around far too long. That's what I've always called it, learning and growing up with BGP. Anyway, the MED. But as I say, the issue here is you're telling somebody else which incoming path to use. Most operators want to determine the outbound path from their network for traffic engineering purposes. So what usually happens, AS64502 in this example will say, well, I don't care what they want. My local pref is going to do this, and it may not be the same. Even over the years, I still get people saying, but I've set these meds, but they're not listening to them. It's like, well, of course they're not. They're overriding them with their own local pref. Okay, jump through this. Deterministic med, that's the Cisco old, well, they haven't changed the defaults like they should have done about 20 years ago. But anyway, you need to do this in Cisco boxes. Everybody else seems to have got it right. So I'll skip through these pieces. You can convey the IGP metric as a med if you want, but health warning with MEDs. A lot of people just overwrite them with local prefs. So anyway, I've included the slide for folks if you're interested in how that would actually function. It just means you can indicate to neighboring providers, this link has got maybe lower bandwidth, or maybe it's more hops through the network, so I don't really want you to use it. Please use this one. I mean, these days, most people are saying, right, now, local pref 1000, don't care what you want. It's what I want for my outbound traffic. Communities are very important. I got to a stage, even in my Cisco career, of saying, look, I'm not going to help you with your network and your traffic engineering, whatever else you need to do, unless you're using communities to try and implement your policies. It's a 32-bit integer, so it's 32-bit attribute. Humans aren't very good with big numbers. I think we're okay up to about 5 digits. Once it's 6 and 7, then we get a bit confused. And so the common usage for communities is to take the 32-bit, split into 2 16s. So the notation is like that on the screen. The first 16 bits, by convention, is your AS number, which is fine if you've got an AS number less than 65535. These days, most of you probably will not. And then, oh, Philip, what do I do if my AS number is 131076? Well, just pick a number. It doesn't really matter what, We've got all these private AS numbers that you can use. So a bit later on in the slide deck, I'll show you some examples of what operators are doing. There's no law that says the first 16 bits have to be your local AS number, but some people get very fixated about it. And then the final 16 bits are whatever you want. There's no standard for what any of these communities need to be. Because they're really for you as a provider, setting policy with your neighbors. That's all communities are intended for. Some people seem to think they're a global signaling mechanism. No, they're not. What does community mean? Look at the English explanation of what community is. It's intended for local policy between you and your neighboring AS. One of my jobs I help with is RouteViews. I'll be giving a RouteViews update tomorrow. Jump on one of the RouteViews collectors and look at prefixes. They're just some incredible lists of communities that have traveled all around the world. And it's like, why are people advertising the internal communities used for policy inside the network to the whole planet? I'm baffled by that. And, with all these presentations from various researchers and so on saying, oh, if you send this community on this announcement, you can make this change on this network halfway around the world. It's like, I don't know why people are... Anyway, we'll come back to this in best practices a bit later on. Anyway, how they work, I'll jump through this as well, but, when did we migrate? I mean, I worked for UK ISP that became part of UUNET's empire. And I think Cisco deployed the code, would have been 1996, thereabouts. And my team then just, within 3-4 months, they'd come up with a policy to replace all, masses and masses of filters and policy language using communities instead. And it greatly simplified the operation of the network. Just because we could rather, this slide here shows, the type of filters that we had to set up just to add a customer. I mean, I carried the pager for umpteen years as well. So 4 a.m. Tuesday morning, I had to go wake up, dial into the network. It was dial in and clear IP BGP and hope everything came back within 15 minutes or so. And if it didn't, I had to then put on clothes and drive into the office about five miles away and figure out what had gone wrong. But that was what it was like back in those days. And when communities appeared, we could do simple things as we could tag the prefix. As it came into our network, we would tag it. And the nice thing was, wherever else we needed that prefix, it was just matching against a community. Oh, this prefix goes to this upstream. Oh, that prefix goes to this peer. And it meant that we could add a customer and the prefix would be visible very, very quickly through the whole internet. So it gave that flexibility. It was just such an amazing change. Okay, jump through all this. There's the vendor policy implementation. I mean, RFC 8642 should be a wake-up call for a lot of people. You can't just assume that your vendor A behavior is not going to be the same as vendor B behavior. And there were quite a few interesting examples in the lead up to that RFC being published about some of the strange differences between different vendors. And it's just how they treat well-known communities, how they set, how they remove communities that are there by default. Again, there was no standard for any of the behaviors. So it's really important to check with your vendor. I mean, I remember early UUNET years, we're going to run a dual vendor network. It's going to be Cisco and Juniper. Like getting those two to work together with the same defaults and the same behavior. I'm sure there's a presentation in two that could have been given about all that. It was not straightforward. Yeah, the 4-byte numbers, what I mentioned, as I was saying before, people get fixated about the first 16 bits having to be your AS. What do I do if I got a 4-byte number? I don't care. It's a 32-bit integer, so you could use a private AS number, or we have RFC 8092, the large, or BGP large community attribute. So now you've got 96 bits to play with for your communities. Just to let you see, they're used in some places, exchange points, some big transit providers do use them. But again, some of the BGP implementations still don't really have the large community support in them. So, if you're using, say, IXP Manager at exchange points and so on, you'll find a lot of internal coding in IXP Manager to manage the policies at an IX are using the large community as an example. But that way you can do signaling to particular autonomous systems about what you want to try and achieve. I'm not really going to look at them because they're not as widely used as I expected that they would be. Path selection, there's an RFC, part of the RFC 4271 says what the path selection is. Every vendor has added its own little bell and whistle, just a little tweak because this customer wanted the tweak. But it's approximately this. I've added in step 3 there, which is everybody who follows Cisco's way of doing things has the weight, which is not an attribute, but it appears in the path selection and it can be set in the same way as an attribute. It's like local preference, but just local for the router. So page 1 here, this is where you want to stay. This is where you're in control of your policy. Once you get into page 2, then you're in kind of, lowest MED. That means somebody else is determining your policy. If you forget to do deterministic MED in Cisco iOS, it's a random best path depending on, if a link goes down, your best path moves somewhere else. This was a classic one, certainly again, I think it was for UUNET also. The best path could be East Coast, then it could have gone to West Coast, and could have gone to middle somewhere. It was not deterministic at all. So deterministic MED appeared, I think it was around about 97, 98. It's standard in Junos, and that way you always had the right result. The best path would change would stay the same no matter if you did maintenance on your main link or not. eBGP path or iBGP path. So if the destination's outside my network, send it out. Then we're starting to look at inside our backbone. And then you've got, multipath pieces. And this is the one where the vendors have just ignored the RFC. RFC says, what does the RFC say? Oh yeah, sorry, the RFC. So the vendors added select the oldest path. Because a lot of the providers wanted that for stability. It doesn't suit everybody. So, you've really got to pick what you need to do. stay with the vendor defaults possibly, but it's always nice doing the demo on a Cisco box, especially in one of the workshops, because folks don't think of this and they go, why is this the best path? And they go through all the steps here, but nobody picks the oldest path because it's not in the RFC, but it's default on most implementations. Once you're down to the lowest neighbor address for the path selection algorithm, things are pretty bad. You really don't want to be in this page at all if you're controlling your external policy properly. Well, at least when I'm doing all the BGP workshops, just stay off page 3. Page 1, ideal. Page 2, then you're starting to get dependencies in your own network. 3, no way. Multi-vendor environments. Yes, I know. I mean, it's so many places I've worked for. I mean, it was kind of fun working at Cisco, but it's more fun afterwards when folks are trying to do I'm going to have 2 vendors. Or even better, I'm going to pick the cheapest vendor. And they have this whole mash of different equipment in the network. And then they've got different priorities for path selection. They've got different path selection algorithms, and things behave different ways depending where the exit is. You've got to try and make sure that the path selection behaves the same way. Otherwise, well, you could end up with routing loops, worst case. So multi-vendor is good, but you've got to pay attention to making sure everything is the same. Okay, policy. I'm not going to go into policy language. Early tutorials, I would plod through policy language, but people either copy Cisco or they copy Juniper. And Cisco's policy language works this way, and Juniper's one is upside down. And if you understand Juniper's one, you'll think Cisco is bizarre. If you understand Cisco's, you'll think Juniper's bizarre. You just have to learn how it works. And certainly if you're using those 2 vendors, you've got to be kind of careful. Because I always say, if you're Cisco, you do this way. Juniper, you've got to stand on your head. And it's kind of interesting trying to have to handle both, and getting the 2 vendors or 2 types to do the same thing is often not as straightforward as it might seem. Anyway, I'll just leave all this because you've got all the different tools for implementing policy. We've got the route maps, prefix lists on the Cisco style CLI, and then you've got all the different policy statements in the Juniper style. Capabilities, these are all extensions to BGP. In the old days, you would just add attributes and things. Nowadays, capabilities, there's a whole list of capabilities. IETF keeps generating more. Are they all used? Well, who knows? But the common ones I see are actually in the bullets on the left. Of course, multi-protocol, because we're using V6 and MPLS and other things. Route refresh, you use that with not even aware of it. BGP ORF is used. Graceful restart, more and more people are using. 4-byte ASNs is a given as well. But some of the rest of them there, I don't know, a lot of internet draft. I have to update this table every year because some get obsoleted, others get the names changed, and so forth. Anyway, at least all these capabilities are there. Unknown capabilities, by the way, I noticed that, especially now involved in the RouteViews project, and some of the folks who want to peer with RouteViews and say, oh, your router's doing weird things. And it's like, I often find that some vendor implementations, if they don't know what the capability is, they tell us, go away, we don't want to talk to you. If you don't know the capability, you're meant to say, I don't know the capability, and carry on. But I don't know, it's actually kind of fun running a global route collector thing. You see some of the BGP implementations out there. It's just, I don't know. How does the internet still work? No, that's Jeff Houston's catchphrase, not mine. Right, scaling techniques. Scaling techniques. I don't know, how does this internet thing still work? You look at some of the original spec. I mean, we had full mesh BGP. Well, it was a big network in the US, collapsed in about, 95? Trying to do full mesh BGP with 60 routers. So that was a bit of an issue scaling, and then grouping BGP peers together. It's obvious stuff when you look at it now. At least the modern implementations kind of make this grouping and scaling standard. But a lot of the older code bases still don't do that. And if you don't know it, that's still jump onto, certainly in my tours around Asia, a lot of people aren't even using any of these scaling techniques, and these have been around for 20 years or more. It's like, well, why are you not using route reflectors? Oh, what are they? Please, really? Philip needs to do more tutorials. Anyway, let's have a look at these. So the peer groups, originally peer groups were meant to help improve sending BGP announcements out. And since the code first appeared, a lot of improvements have been made so that it's all done internally. Peer groups now, and Juniper's equivalent, I just find as a documentation thing. It's just, you can build configuration templates, grouping peers together. It just makes it easy for the human to manage. And we still have to have humans to do a lot of this stuff. So it just makes it easy to group like peers together. Originally designed for speed, but these days it's just easier to read and understand the configuration, easier to build your templates. So again, I'm not going to go through them. There's Cisco's version, and I've got a Juniper version example here, just again lifted from, well, real world, but addresses changed to protect the innocent. You can use these BGP grouping for external BGP as well. You see that especially at exchange points. If you have an open peering policy, you've got a standard outbound peering that you do with your BGP peers and exchange points. You just use a peer group, apply the peer group to that neighbor, and it keeps things simple and easy to manage. Dynamic reconfiguration, so route refresh. This was a lifesaver. It meant the end of the pager, at least as far as, and the 4 a.m. maintenance every week, when Philip or his team had to wake up and reset the BGP sessions because that's all we could do. Route refresh meant that, oh, we need to change policy. Oh, we can just get the router to do it automatically. So route refreshes was actually very, very useful. The reason, before we had route refresh, was BGP only sends updates. So if you got an update and your policy said, oh, I don't want this, or you had changed, say, a local pref or something, you threw away the original update. You only had what you had changed it to. And so if you wanted to change your policy again, you had to go and get that update. And the only way in the old days of getting the update was shut BGP down and then bring it back up again, which is not really very good. Fine for an experimental network, but I don't think the internet is experimental anymore. So having route refresh was the lifesaver because that meant you could sit on the router, send a message to the neighbor saying, send me everything all over again. And that way you could implement your new policy without breaking connectivity. So that was the history of that. I'm not going to go through the detail, just skip through this. There are still people today who are not using route refresh. They just do, I'll reset the BGP session. Please don't do that. It really causes bad things. Well, it breaks connectivity for your customers. But we've got 970,000 prefixes in v4, 200,000 in v6. That's a fairly big hit on the router control plane. So a BGP reset is going to upset your neighbor. There are PKI stories that I'll come to somewhere a point in the slides as well. That we really got to be kind of careful doing these hard BGP resets. Here's the route origin validation story. So ROV, well, we had the tutorial before talking a little bit about RPKI. I wish I had time to do a bit more about this because it's a BGP best practice, but I only have 2 hours, which is not even enough time for this. But one interesting thing with route origin validation, which not many people knew about, is how is the incoming policy applied on routers today? If a prefix goes from, say, validation state valid, in other words, there's an existing row, and this is, the AS is announcing the prefix, and it's all fine and good. What if it goes from valid to invalid? Or if it goes from invalid to valid? Well, some implementations have this thing called edge rib-in, which is the adjacency rib-in. They store everything that's actually received. And so when validation state changes, they can just pick the prefix up from the edge rib-in, what has been stored, implement the change in policy, put it into the BGP table. but others don't. Others send a route refresh. Hello, neighbor, send me 900,000 prefixes again because one ROV state has changed. This has knocked out some fairly big networks. So the ones that don't maintain edge ribbon, not mentioning the C vendor at all, send a route refresh. And so, yeah, I've seen cases, and I actually see some of it on RouteViews as well. You see some of these neighbors are just hammering away. Ooh, ROV's changed. I'm going to hammer away at you all over again. So this has caused some fairly big issues. So generally, if you're using Cisco routers, I mean, the latest software does fix this, apparently. But the only workaround on Cisco boxes, if you're going to do ROV and not kill your neighbors, is turn on soft reconfiguration, which was the Cisco pre-route refresh hack, to be able to have folks using that equipment actually reset BGP sessions or change policy in BGP sessions. So this is jumping miles ahead in the tutorial, but I thought I'd put it in here because it's very relevant for route refresh. You know, changing validation state if you're using Cisco boxes, or if your neighbor's using a Cisco box and wondering why you're sending huge amounts of updates to them, it's because they're saying, hey, send me your full table all over again. Route reflectors, that's the way we scale the iBGP mesh. I think in Seattle I said nobody uses confederations again, and I had the usual few people coming along, how we still use them. Yes, people still use them, but deploying confederations today is, I don't know, it's pretty unusual. Almost all the networks I've helped in the last decade, we're doing route reflectors, really from day one. You certainly want to avoid something like in the picture. And yes, I drew every single line in that. PowerPoint doesn't have anything to make it easy. And that's only 14 routers. What if you got 1,000? How many iBGP sessions do you have? Would it even work? Is your control plane big enough? So anyway, route reflector is simple. It just means that, remember I was saying at the start, iBGP speaker only passes on prefixes it learns from outside or locally originated. All this does, a route reflector, is take the prefix from one iBGP speaker, pass it on to the next one. Of course, you can't just change all the defaults to do that. You need a special configuration in there. So that was the picture. You need a special configuration. You've got to indicate on the router what the route reflector is and what the client is. And different vendors have different ways of doing it. So generally, you've got the rules here, just so that we don't end up with BGP announcement runaway loops. So normal BGP speakers have normal BGP behavior with each other, but a client of a route reflector, if it sends a prefix to the reflector passes it on to other clients and normal speakers. Likewise, a route reflector will pass on prefixes to all the clients, but they won't pass on prefixes from one normal BGP speaker to another normal BGP speaker. So in real world, it's very easy to set up. I mean, most of the implementations I've worked with, your core route and the point of presence is the route reflector. The access routers, whatever you have, are the clients, and you just build infrastructure that way. But you know, some of the big networks I've helped build, you know, they're like 3, 4, 5 layers deep of route reflectors. How far does this scale? I've no idea. I've not seen anybody who's broken the scaling limit. So anyway, we'll just jump through all this, you know, just how to design and build and so forth. I mean, my advice is always follow the physical topology. That's out of bitter experience. Other people beg to differ. Well, that's fine. I just want to share my bitter experience. Other people may have other experiences. The core routers in the POP, in the traditional design, they're the route reflectors. The packets are always going through the core routers anyway. Again, the principle of least surprise. It keeps things simple and nice and scalable. Won't talk about migration. Communities. Okay, let's look at communities. I think I said earlier, you know, helping networks, especially when they're looking at policy, trying to scale infrastructure, my first question is usually, are you using BGP communities? And if the answer is what, then it's like, this is going to be hard. Because trying to implement policies and trying to scale networks is really hard without using BGP communities, in my general experience. And the thing is, most major network operators make extensive use of communities. Internal policies, so iBGP, inter-provider relationships, so MED has disappeared a long time ago for most folks, and customer traffic engineering. Yes, you can actually give your customers some communities to use to traffic engineer on your exit points. It sounds a scary thought. Some operators don't allow this, others give limited, others, yeah, go for it, have fun, because they don't want to have their NOC involved in dealing with customer traffic engineering issues. Here's some well-known communities. The no export one is very commonly used. Tag a prefix with that. It tells BGP speaker not to announce it to any external neighbors. So that's a good way of keeping a prefix inside your own AS. Or when you announce a prefix to a neighboring AS, is to tell them not to export it anywhere else. Well, unless they override the no export, and then you've got a nice big leak to the rest of the world. No advertise does what it says. Tag a prefix with that. It's not advertised to any other BGP speaker. No peer was a great idea, I thought, but I don't know, hardly anybody uses it. And every time I did the tutorial at NANOG over the years, there was always somebody in the audience say, but we use it. Yeah, but you're one operator using it. And I really don't know. And I think the issue really was that I felt at the time that there was no keyword in the major vendors. Right? If you go on to Cisco, you've got no export, no advertise, it's there as a keyword. Whereas no peer, it was like, well, what does a peer mean? Is it a BGP peer? Is it a money peer? You know, and that, I think that kind of, well, didn't confuse people, but it wasn't so easy to conceptualize as the previous two. The next one, black hole community. Hopefully people are using that now. That's the remotely triggered black hole filtering one. It's now got its community many years after Chris Morrow first talked about RTBH. When was that? 2003, 2004 or something? So we finally got a community for that, so 666. And then the graceful shutdown, which is the 65535:0, which is letting a peer know that, hey, we're going to shut down this BGP session soon. And what they will then do is look for that community, set an incredibly low local preference on the link, and so the traffic will find another path. I think I've got some examples here. I've talked about this before. Is it here? Yeah. So here's an example of no export. You could be multi-homing between on multiple links to your upstream provider. Well, the whole world does not want your /24s. I'm going to come back to all this soon. Whole world does not want your /24s. So what you do is, when you're multi-homing over, say, 3 links, as in this example, you leak subnets on each link. But the world does not need to see your traffic engineering to your upstream provider. Tag those subnets no export. It tells the router G there, don't announce these prefixes to the internet. So that's the no export. It's used very simply for things like this. Very common use. The no advertise, here could be an example. Router E is announcing a prefixes, well, prefixes could be a default and something else to router B. Router B, they tag the default was no advertise, and the default just sits on router B, doesn't go any further than that. Maybe you're using the IGP to distribute the default route instead. So you can tag a prefix, no advertise. It's much easier than trying to put a prefix filter on the BGP sessions with A, C, and D there to block the default. Just tag a no advertise when it comes in, and the router does the work for you. The no peer, yeah, well, that's the no peer, how it works, but I'll leave it there for reference. What else? The black hole community, this is the RTBH one, how we use that. So for example, 164.6.65 as a host route, maybe that is being attacked. Huge DOS attack against it, so you announce it to your upstream router B. Tag it with the black hole community, 65535:666. Router B is looking for that community. If I see the black hole community, set the next hop to the null route. 192.0.2.1 is routed to null across the backbone, so you end up, that's the null route. And so any incoming traffic into 645.0.1 intended for that host in 645.0.2 gets dropped in the 645.0.1 network. So that's how all that works. If that was far too fast about how RTBH works, I think I've got, well, umpteen tutorials that show how that can actually function. What else? Graceful shutdown, similar story here. Again, graphics showing how graceful shutdown might work. There's nothing worse when you've got a few gigs of traffic on a link and your neighbor suddenly, oh, I'm shutting BGP session down. Well, you probably don't care, but your end users certainly will, because everything just stops until the router has figured out another path, which can be a few seconds, few minutes. So graceful shutdown at least is a way for them to say, hey, I'm going to shut down this link because I'm going to take the router out. It lets you put a very, very low, this is the before picture, so standard local prefs, the after picture, set local pref 0, another path will be found, could be through another provider, and so BGP will do its thing, next best path, traffic will redirect, and you don't end up actually black holing anybody while router E is being, well, or whatever, or the link has been broken. So really want to encourage folks to use graceful shutdown as much as possible, advertise it in your policy that you do support it, and that way we can just be a little bit more gentle on the internet infrastructure. What else? Oh, I've just got some community examples here. Let's see what they are. So customer edge. So this is all about no need to alter filters on the border router when adding a new customer. There's nothing worse than having to trail around all the different routers, adding prefix lists and so forth, just as a new customer comes on board. If we already set up the filters to do filtering based on communities, then we just tag the customer accordingly. I've got some examples here. I mean, this is stolen from various folks that I've helped over the years. It just gives you the kind of example of what could be done. I'm not going to go through in detail. It's more shared as an example of what could be used. And I've got things here like, maybe you've got a BGP customer who only gets transit, or a customer who only gets announced to your private peers or exchange points or whatever else. You can tag each customer accordingly and announce them in various places accordingly as well. Once you have this in place, your sales folks can go and have fun about what services they can sell, because it becomes very easy for you to manage where they get announced. So I'm not going to go through the whole detail of this. Yeah, I'll just skip through this one for sake of time. But having a look at some of what network operators are doing out there might help. We've got the well-known communities, and then, so umpteen years ago, I was doing this presentation and I was whining that there was no real documentation about communities in use. And one of the folks in the audience came to me afterward and said, well, I'm going to start collecting them. And so, I think it's still reasonably current, this One Step Consulting webpage. I hope it is, because I haven't looked probably for a year or so, but I hope it's still there. Collecting all the communities that network operators around the world were advertising. And then there was the NANOG 40 tutorial, which is kind of funny watching it. I think it was Rob Seastrom and I forgot who else did it. And it was kind of interesting watching it, because it was a lot of what I had in this tutorial about, well, these are the ones that are commonly used, and they are commonly used by a lot of folks, but how we never got an informational RFC saying, these are what people commonly doing through, I really don't know. I mean, there was an attempt to try and document, but the best we've got is really that NANOG 40 presentation. This is NTT's example. In recent years, they keep changing the URL. It used to be a nice short URL, but for some reason, it just seemed to get longer and longer, and the website gets fancier and fancier. But if you look at the type of communities listed there, you can see what they're doing. 2914:666 is the RTBH community. And they've got various other ones, and you go through that list, they'll tag, where the prefix entered the network. I've got a lot of operators I help who are customers of NTT, and they have, I wouldn't say they have fun, but they certainly have, it gives them a lot of options, but how to do traffic engineering with NTT. And it makes it good for them. It makes them good for the customers that we always get the closest or shortest path to destinations. So that's NTT's one. We've got Verizon Europe. Very, very familiar set there from the 90s. I recognize a lot of those ones, but it's the same type of idea. This is in the AS object on the RIPE routing registry. And then we've got Aurelion, AS1299. They've got a long list of all the communities that are supported. And again, I've got folks who buy transit from them. And again, you can do the same thing. You've got things like you can set local pref 50, 150, you can do prepans, announce here, don't announce there, which makes it quite powerful. BT Ignite, so the AS5400. Again, a list of who they connect to, how they peer, what they can do. Don't announce to these folks. And again, over the years, I've had folks who are customers of this network and can use the communities to good effect. Level 3, huge list that level 3 have, 3356. Well, it's still in the RIPE routing registry as 3356, whatever level 3 has become these days. But you see at the bottom there, 3356:9999. You can tell it was somebody from the UK who did this because 999, well, 4 nines is the emergency number. If you're inside an office, you dial 9 to get out, and then 999 calls emergency services, in case you're wondering. So anyway, my advice, come up with your own community policy. There's a lot of documentation out there what network operators are doing. If you're not using communities today, seriously think about trying to do it. Be inspired what other people have done. Don't just shut yourself in a little room trying to dream up something from scratch. We did that in 96, 97. The 25 years at least of practice out there of using BGP communities. Have a look at some of these policy examples I've given you. There are lots of others, and be inspired by that if it helps you just operate your network a little bit better. Right, okay, so now this is the bit, that's not too bad. So the rest of the time I want to spend just looking at best practices. So we'll jump through iBGP, IGP. So ISIs, OSPF I've talked about. Infrastructure addresses is what we put in there. We don't want to be carrying 25,000 prefixes in ISIs, which I've been lectured about quite a few times in my early years of trying to do these things. Oh, but we carry 20,000 in OSPF. Well, that's nice. It's not designed to do that. Infrastructure addresses only, if you want to try and make this scale, so point-to-point links, loopbacks. At least with V6, you don't even need point-to-point link addresses. I know operators now, you just have a loopback, link local is all you need. So the V6 backbones are just the loopbacks. Got 500 routers, I've got 500 entries in my IGP. So V6 helps with that way. You can't really do unnumbered links in V4, unfortunately. Well, at least not on the kit that I've tried. So I've talked about iBGP, eBGP, the model we've seen before, and then vendors have got these lovely redistribution commands. These are not lovely, they're not helpful, they are a guaranteed way of making life miserable for you. Keep a distinct separation. You'll never need to carry or move OSPF or ISIS routes into BGP or vice versa. Right? You'll never need to do that in a traditional network setup. I'm not talking about MPLS or anything else. You don't need to do that in a traditional setup. Right? So just don't go there. We learned that in 95, 94, and there's still people determined to make the same mistakes we were making 30 years ago. So please don't. What else? eBGP default behavior. So this is definitely a case of closing the door long after the horse has run away and is probably in the next country. But anyway, RFC 8212 is trying to define the default behavior of BGP. So route propagation without policies. So RFC says, if there is no policy, you propagate nothing. Accept nothing, send nothing. Unfortunately, there are certain vendors, if there is no policy, it means open season, send me everything and I'll send you everything I know. So RFC 8212, it's a best practice. Please do it. If your vendor doesn't do it, put it in an RFP, make it mandatory as a default. This is the only way they'll change. I worked at a vendor for 13 years. When you work at a vendor, you can change nothing because the only thing that talks is money, right? If a customer is not going to buy product and it's a big buy, then they will consider doing things. I mean, I can talk about all the bugs I've seen for years and years. I could never fix any of them because I couldn't put a monetary value on the bug. And it's just like, well, anyway. So these days, in a lot of the configurations, and we talk about it in manners as well, the manners name for best practices we've been doing forever. When you're setting up eBGP sessions, for goodness sake, make sure you've got incoming and outgoing policy. Even if the policy is allow everything in and out, at least you've got some policy there. Get into the habit of always making sure that it's there. Because not everybody is like, well, here's FRR, for example. FRR, now by default, no prefixes are sent or received unless you have policy. Well, you've got the eBGP requires policy knob. You can turn it off if you want, but you need to get out of the habit of turning off good defaults. And so FRR, at least it's no longer announcing or receiving anything by default, which is a good thing. So if you break your filters because you've just somehow mistyped something, you're not going to break the whole internet. Aggregation. Yeah, usually when I hear Jeff talking at NANOG, he's often talking about the routing table and how it's all doomed and the whole world's coming to an end. And he's been doing that for 20 years and we're still here. But yeah, I don't know. This is what I don't know what to say, to be honest, because the size of the table today, what is it, about 960, 970,000 prefixes? And when I was updating the numbers here for the tutorial deadline, it was like there are 588,000/24s in that IPv4 table. Most of them are junk. They don't do anything, at least from all the views that I have. They are just there. And we can't say that IPv6 is wonderful and new because the same garbage is happening in IPv6 as well. There's no way the registries have handed out 97,000/48s to end sites. No way at all. Well, I know there isn't. I've gone through the whole list to check and see. So there's this kind of, I don't know, aggregation. I mean, it's, I think blast from the past, Sean Duran when he's at Sprint and the, fairly aggressive filtering that they were doing. And this is like late 90s, early 2000s, trying to get people to do best practices. I guess the vendors are just making faster and faster routers and people don't care. Because that's what it feels like. But, why do we see all these v424s? Why do we see all the v648s? Especially when they all have the same AS paths. It's not traffic engineering by and large. It's just junk for the sake of it. So, I see a lot of this still when I go and ask operators, why are you doing this? Oh, I only announce my customer prefixes when I only announce the address space, I should say, when I give it to my customer. Well, what about the address space that you still got sitting in your back pocket? Oh, I don't announce that. Well, don't you realize that somebody else could then go and borrow it for maybe an hour or two and send mountains of junk or spam or whatever? Oh, they do that, really? Yes, they do. So, we've still got this kind of thing of, I'm only going to announce the prefix when my customer is using it. And then I say to them, so when your mobile phone is switched off, what happens to people who try and call you? Do they get a number unobtainable? Oh, no, it goes to voicemail. Well, where's your voicemail? Oh, but that's different. No, it's not. It's exactly the same thing. Right? So there's just this whole thing of we're not going to announce covering aggregates because it's not all the address space is used. I don't want to get all this junk traffic for address spaces not used. That's what your null or discard interface is for. Just dump it in there. Oh, what's that? But here's the big thing. And, there's some parts of the world, I'm not going to name them exactly, you can go to who are the incredibly bad behavior in this part of aggregation. If that provider has a link that goes down, you're off air for half an hour. thank goodness for mobile phone roaming, because you can get off the hotel network or the office network onto your mobile phone, and you can still get internet working. Maybe that's the problem. So, but this is what happens. They don't announce it covering aggregate. The customer reboots the router, and that, whatever prefix, ripples through the entire internet. How many autonomous systems? 77,000 almost? How many are carrying the full table? Most of them. They're all going to see that update. They're all going to see that update, and everybody sees it. A light gets turned off in Toronto, and it's visible across the whole world. I mean, we don't have that for anything else, so why is it okay here? I really don't know why this is still seen as something that's okay to do. And a lot of the operators who are involved in this, and I go and try and help them, or even talk to the upstream providers. Why do you allow this? Oh, well, the customer's paying me. Well, yes, but why is nobody doing this? Just announce you're covering aggregate. We really don't care what all the little local details are about. Announce you're covering aggregate, you get nice stability. If the customer reboots the router, the internet works again. If you've got to change the fuse or circuit breaker in your house, do you want the electricity company to withdraw your service and you've got to phone them up and try and get them to reconnect? I mean, that doesn't happen in any other service industry, but somehow here it still seems to be perfectly fine. Anyway, yada yada. Many operators do not understand the importance of separating iBGP and eBGP, and that's really what it comes down to. There's no border router filter. Oh, it's my prefix range. I'll allow the whole thing down to /32 out. And it's amazing. You'll see, point-to-point link addresses, loopback addresses appearing in the global BGP table. A lot of people are really good about filtering smaller than 24. But again, with RouteViews and my own routing table project, there's some places you can just see details of people's internal networks leaking out to the global internet. There we go, 960,000 prefixes in this view that I have this one is from Dixie, which is the wide exchange point in Tokyo. 76,000 autonomous systems. It's just as bad in V4. Look at the number of 48s out of 200,000 prefixes in the V6 table. And then my question always then is, how many /48s in a 32? Imagine if every operator with a 32 subdivided them into 48s. What route did you need to carry all that? It doesn't bear thinking. And then it's, efforts to improve aggregation. We've had the RIPE Routing Working Group has done work, RIPE 399 covered best practices for announcements. 532 did the same for V6. Again, it's recommendations because document what we're doing. If it's not in a textbook, then universities don't teach it. So documenting as much as we can of just operational best practices. CIDR report, Tony Bates started years ago when he was at RIPE NCC, and then I ran it for a bit when I joined Cisco, and then Jeff left Telstra and started doing all his research things. So he now runs it. And, there's a nice little website, and you can see what's going on in the BGP table. You can pop your AS number into it, and you can find all the horror stories. So, I've got some example horror stories of why are people doing this? This one here, who's this one? This is FPT in Vietnam. Why are they announcing all these 24s? I mean, look at the paths. They're all the same. Exactly the same. There's no traffic engineering happening. So why are they being announced? TPG in Australia, same thing. Why? Just because they can, and nobody's complaining about it, apart from Philip Smith. Seems to be. And I'm a TPG customer. Anyway, Orange in Spain, mobile network. Okay, so there are some path differences here, but really, do we need to see every single mobile tower? I think that's what that is. /22 probably is. No idea. So, router memory maybe isn't a problem. We've got 16 gig of RAM in the routers. We've got supercomputers as the control plane. Maybe it's not a problem anymore. The amazing thing is, that the internet still is converging, pardon me, at a suitable speed. BGP updates, again, from one of Jeff's report. I mean, this is not really linked to the CIDR report, but it's also on his webpage, potaroo.net. And this is looking at the updates as he sees them at his collection point. But you look at the updates, number one update in the world is Amazon. The 3.7% of all the updates in the global internet are caused by Amazon, followed swiftly by UUNET in Mexico, which is a mobile network. And then we've got ETB in Colombia, BSNL. Now, we all know what BSNL is doing. They have got an automatic load balancer. They were quite open about it. Automatic load balancer. That just load balances traffic and all the external links because they don't have humans anymore. But that's what it does to the BGP table. We all see the automatic load balancing. And there are probably others. I'm not going to run through the list. You look at the active prefixes, most of them are /24s. There's some bigger ones that are bouncing quite happily. I don't know what the service would be like on the other end of one of these links. Maybe people don't care. Or they just jump onto their mobile phone when their terrestrial link stops working. It's just, I don't know. I really don't know. V6, Alestra in Mexico has just been top of that list for years. Unstable, or at least they're causing a vast amount of BGP updates. Maybe it's the BGP implementation. Amazon is high up in the list as well. And what else? We go through it. There's a whole raft here. Again, the prefixes. Look, we've got a /32 at the top of the list. I mean, that one I know about. Why it's at the top of the list? Because their link is really unstable. And we see the impact like that. But Trinity Cyber, I don't know. AS7296, don't know. And so on. We can go through that list. These are these unstable networks. Nearer the bottom, have a look at that. Amazon, bring your own ASN. We see it in the global table, unstable. What's that going to feel like as an end user? Anyway, aggregation could be a lot better. But obviously everything still works and people aren't unhappy about it. You're very happy paying the vendors for huge amounts of RAM in your routers and huge control planes. Obviously, plenty of money. So, routing table v4 today could be 300,000 prefixes or so. The v6.1 could be about, what was the v6.1? It could be about 120 thereabouts. But you're happy enough paying for the bigger routers, so there we go. Okay, receiving prefixes. This is just the health check. Don't accept any old rubbish that turns up. Check the WHOIS databases. The 5 registries are authoritative for the address space that's out there. Nobody else is. It's the registries. So check their databases. At least APNIC has got this nice joint WHOIS tool that I use all the time. It goes and asks the other registries. If it's not an APNIC one, it'll go and ask the other 4. You can go and check it up. If the organization isn't what it says in the WHOIS database, then, well, why are you announcing the prefix? Here's some examples. I just put in, check what you're actually getting from your customer. Don't just any old person turns up. But, a lot of places, any old rubbish can get announced. Nobody does any checking. Just show me the money. It's not really a good way of running a network. From peers, also, what are you expecting to get from a peer? Some parts of the world, this is well documented. It could be, whatever the documentation used. It could be routing registry could be used, or paper documentation, email documentation, whatever. Other places, I've seen peering. Oh yeah, I'll get my neighbor to do the filtering. This is Exchange Point. They've got eBGP session up with no filters. So you trust what you're going to hear? What if your peer sends you the full BGP table? What are you going to do then? Nobody can really answer that. So, IRR toolset is still around. I don't know how useful it is anymore, but lots of people use BGP Q4, uses NTT's IRR database by default. That's a good way of building filters based on what peer is expecting to send to their neighbors. Or you can do it by hand. What about your upstream provider? Do you really need 960,000 prefixes? Well, if you're a transit provider, you probably do. If you're an end site that's multi-homing, you probably don't. Well, unless you've got a nice big router and just want to have a look at the BGP table. But do you really need the full BGP table? And, I see more presentations now from operators, certainly in Asia Pac, who are talking about, oh, I've stopped carrying the full table, and this is what I've had to do. They've actually had to learn a little bit about how to filter prefixes, understanding what's close to them, because that's all that really matters, how to get to local content providers or content caches, and then other sites of interest. That's where all your traffic flow, your net flow, your JFlows, IPFix are all useful to find out who your important peers are, where your traffic is actually going. Know the traffic that's coming in to your network. But there's usual good practice. Don't accept default unless you need it. Don't accept your own prefixes. Believe it or not, some people accept their own prefixes, then they wonder why those problems happen on their networks. The special use prefixes for v4 and v6, RFC 68090 describes those. v4, don't accept prefixes longer than /24. I mean, that's a historical class C. Do you see them smaller than that? It's a question. I don't know. I mean, what should actually happen? Do we want to deaggregate the entire v4 internet down to /32, all 4 billion prefixes? For v6, 48, I mean, that's the minimum delegated to a site. Do you really expect to see smaller than that in the v6 table? What does 2000/3 look like if it's all 48s? Go away and think about that. It's pretty big. Team Cymru keep a list of bogons. That's the bogon reference you can get from the website. Or they can give you a BGP feed. I have quite a few folks I've helped over the years who use Team Cymru's BGP feed. And it works the same way as RTPH does. They send you the BGP feed, you set the next hop to null, and that way you stop those prefixes from impacting your traffic. What else? What else? These are the typical v4 prefixes. It's probably not, well, I mean, it's what I use. These are the prefixes you will not see. So your prefix list, if you're getting the full table, should at least have this in it. You don't want to see this stuff appearing from anybody. But you will see these in the BGP table. At RouteViews, we see some of these too. So why do we see them in the BGP table? v6, ooh, that's exciting. It's gone blank. So I don't know what's happened with the PDF conversion, but anyway, it should be there. There's a list for v6. It'll be on the, maybe it's just compatibility between Windows and Mac OS. So sorry about that. Does it, if I go back? That's weird. Okay, there is a list for v6 as well. It's a shorter list, but there are also some prefixes that you should not be seeing in the global table. So pay attention to what you get from your customers, from your peers, your transit providers. There's not any police looking over the internet. It's our responsibility, all of us, to make sure that we keep this thing actually functioning. So it's a responsibility of all of us as network operators. What about BGP attributes? Right, the attributes are sent as part of BGP updates for each prefix. So common attributes you need to be aware of would be MED, AS numbers, BGP communities. Right? Only the public AS numbers are routable. But again, if you jump onto places like RouteViews, it's amazing what you can actually find that people are sending. And how do these other ASs get beyond filters? Probably because nobody's filtering them. So what about MEDs? Well, MED is something you use to tell a neighbor entry point into your network. But these days, honestly, they're not really much use because most people will have a local preference determine the outbound policy from their network. Right? Most of them will do that. Common practice, if it's somebody is your customer, highest local preference. If it's somebody you peer with, next level local preference. If it's somebody that's going to cost you money, lowest local preference possible. Right? You always want to try and push traffic over peering links. And you definitely want traffic for your customers to go over the link to your customer, not through your peer or your transit provider just because your customer connects to them as well. So MEDs these days, I I really don't think there's much use anymore. Foregone AS numbers. Well, you should see ASs in the range 1 to 64495, apart from 23456. Some of you might have been around when 32-bit AS numbers were first deployed, and did any of you see the operators who were renumbering the ASs from whatever it was to 23456? That was not what 23456 was, right? You would never ever see 23456 in the BGP table. That was not the intention. But it was fun in those days, 2008 through to about 2012, seeing 23456 appearing, because somebody decided they were going to either insert it or renumber the AS or whatever. And then the rest of the AS range is 131072 up to 458751. That's where IANA is handing out AS blocks to the registries from. Everything outside that range is either documentation, private use, or IANA reserved, and should never appear in the BGP table. Anybody filtering them? What about prefixes coming from these other autonomous systems? Do you allow those prefixes? Do you allow the AS numbers? Of course, then, what does the AS path filter look like? Well, I thought I'd do it for fun. So if you're using something like BIRD, which is the most common route server daemon used at exchange points, it's actually pretty easy. So this is actually lifted from IXP Manager. It's the config that IXP Manager puts on BIRD. And that will filter the AS numbers to only allow the public in-use range. Nice and easy in BIRD. How on earth do you do it in Cisco iOS? You know the Cisco iOS AS path filter? Well, I think this works. It looks pretty plausible. I'm not very good at regular expressions. There's probably an easier way of doing it. So is any wonder that nobody's filtering ASs, if that's what you have to try and do to make it work? So yeah, we need better CLI tools from the vendors to make filtering, because BIRD one's pretty simple. And I think Junos one, it can be done pretty simply like this as well. I need to put a Junos example in, but I mean, the AS path regular expression style from Cisco and all the copies, nobody will filter AS numbers just with something like that. But we have to, because again, look at RouteViews or other collectors, you'll see an amazing abuse of AS numbers and prefixes from those. And why does this stuff work? What about communities? Well, communities, as I was saying earlier, internal policy within an AS, external policy supported by a peer for onward routing policy, filtering, traffic engineering. And I've talked about the implementations before. Check your vendor implementations. But what about community value that you accept? Don't accept ones that are not expected. If you've got communities you use internally, somebody could be announcing a prefix to you with your internal community that does things in your network that they're not meant to be able to do. And I've seen a few presentations over the years where people have demonstrated, researchers have demonstrated how to do things in providers' networks on the other side of the planet. So be very careful about what you accept. Right? BGP communities are not a global thing. It only should be between you and the neighboring network. Right, so, I've got some examples here, just using the iOS CLI as an example. Match what you expect. Otherwise, if you get other rubbish or whatever it is, overwrite it with something internal. Don't send out community values that are not needed. So that avoids propagating internal communities to other networks. So just overwrite all your internal stuff with one thing that can be used externally. And that's probably the easiest way of doing it. What else? BGP attributes, we've talked about them, that's fine, that was a summary. Interconnection best practices, that's a bit of a step aside, but I thought while I was talking about communities and peering and so on, I should look at this. The types of peering I think you probably should be aware of. Private peering is the private wire between two operators, so private interconnect, direct connection. Settlement-free peering is when you peer with somebody, but you don't exchange invoices. I mean, it seems bizarre to exchange invoices and try and call it peering. Paid peering is what I'm referring to. Most peering is settlement-free. Bilateral peering happens at an exchange point. Same idea as private, but you set up a direct BGP session across common media. Multilateral peering is when you can't be bothered setting up 200 BGP sessions. You talk to the exchange point route server, and you get everybody else who talks to that route server. Mandatory multilateral peering is this kind of dream thing that regulators have to force everybody in a country to peer with each other. It really, truly does not work, but we still get people who think it might work. And then the type of policies that operators have. Open peering means I will peer with everybody. So that usually means you peer at a route server, at an exchange. Selective peering usually means I want to talk to you first, check that you're human, check that you're nice, and then we'll peer. Right, so selective peering means they will not connect to a route server. They will set up a bilateral with you or a private peering with you. Restrictive peering is, go away, please don't bug me. In other words, they will come and talk to you if they want to peer with you. Right? And so, you know, if you've ever been to any peering fora, I mean, if you're running a network, you're interconnecting with others, going to a peering fora can be pretty interesting. And, you know, open peering, you know, there's no need to talk to any of those folks. Most of the peering fora activity is around the selective peering to look at more opportunities to interconnect networks. Whereas restrictive peering tends to be the biggest operators who want to decide what they're going to do when they do it. Documenting your peering. For goodness sake, please use the peering DB. I'm not trying to promote peering DB, but I am promoting peering DB because I've used it for years. With my RouteViews hat on, you need to be in peering DB, otherwise we will not talk to you. Seriously. Most big content providers say the same thing. Most of the tooling, the automation that's set up, uses peering DB to figure out peering opportunities. If your exchange is not there or you're not there, you can forget about Meta and all the other folks ever talking to you. Right? So it's easy to set up. It doesn't cost you money. It's a nice community project like RouteViews is. But you know, they always look for your support. So if you have an AS number, put it in peering DB so that you're there. Go to peering fora. I mean, GPF is the North American one. But you know, it's not really global, but anyway, it's the North American one. We've got peering fora all around the world. I'm off to Peering Asia in a couple of weeks' time. That's the big peering forum. It's in Jakarta, Indonesia. It's a nice big event. But every region has their own. A lot of countries have their own peering forums now to try and encourage operators to interconnect locally, because that's what's important. IXPDB, that documents all the exchange points. So it's kind of a spin-off from peering DB. And this is a EuroIX project, the European Exchange Point Association project, just to document exchange points. If you're using IXP Manager to operate your exchange points, so it's just a software suite that INEX in Ireland put together a few years ago. Most IXPs I know use it. You're automatically set up in IXPD. It's just to try and improve documentation for interconnects and so forth. So some examples of peering DB, we just jump through those. The routing registry. So looking at best practices. Routing registry, you don't have to go hugely to town to use the routing registry, but having some basic entries in there is actually really important. A route object is the absolute minimum. If you want to talk to likes of Google and so forth, you need to have a route object. Otherwise, it's just not going to happen. So you can create these IRR objects via the database web interfaces. And we're here in North America. I guess most of you will be ARIN members. Some of you operate in other parts of the world. You'll be RIPE NCC or APNIC, and LACNIC, of course, and APRICOT. Each of them take part in the global internet routing registry. Some ISPs run their own parts of it as well. And we have also the RADB, which is part of the internet routing registry. Just note today, because we're using RPKI, route origin validation, ROAs are now created. These will take priority over IRR entries. And I think it's been emphasized enough here in the last 2 days, for goodness sake, please sign your ROAs. And that way we can be absolutely sure that the prefix being originated by the AS is actually valid. Because there's a nice little industry of taking over prefixes and announcing them from random ASs. So we need to be quite serious about that. Okay, so which Internet Routing Registry database to use? If you're a member of a registry, please use theirs. If you're not a member of a registry, so those of you with legacy address space, that's what RADB can help you with. RADB upgraded to IRD version 4. So a note with this, objects with RPKI invalid cannot be created. Seemed to be quite fashionable for the last 10 years for some big operators to dump the entire global routing table into RADB and pretend they were originating it from their AS. It caused huge amount of issues for some of the folks I've been helping because you got these bogus RADB entries that they couldn't get rid of because they weren't the record owner. Well, IRD version 4, now you cannot do this. So existing RPKI invalid objects will not be visible in a query, and they can't be modified either. So at last, we've got a nice big cleanup in RADB as well. So we have this thing now being actually quite useful. And, you know, as I say, some operators also run their own. So NTT is the famous one, running an part of the Internet Routing Registry. If you're a customer, you can put in there. You don't have to, because they will look at the registry Internet IRR as well. Route object is the minimum you need. It lists the autonomous system number originating the route, which is actually the same as your ROA. In fact, now if you create a ROA in some registry databases, you automatically get the matching route object. So that's quite a nice place to be. So I've just put some examples here. I mean, these are probably, yeah, they're a little bit old, 2018, but it gives you the idea what a route object looks like. You've got the prefix that's being announced, the AS that's originating it, and, well, the sources. This is an APNIC version of the IRR. AS object lists network information, contact information, and the routes being announced to neighboring autonomous systems. So it's a simple attempt, I suppose, at documenting routing policy. Simple attempt. It's not meant to replicate the CLI on the router, but it's to try and give an indication of who you prefer, who you peer with, and so forth. It depends which part of the world you're in. I mean, I'm European origin, as you can probably tell, and you know the Internet Routing Registry, AS objects, are heavily used in Europe. They are in Japan as well, but you know, parts of Asia where I now live, not really. And you know, so AS object, probably nice to have, but it just depends on which part of the world you're in. Or some people will set them up when they get their autonomous system number 20 years ago, and it's never changed. But you know, at least it documents relationships between different ASs. AS set is a handy shorthand for documenting all the autonomous systems that you're providing transit to. So here's one example. You know, it's just listing all the ASs that are customers of this particular transit provider. So it's a nice shorthand if you're trying to document policy more in your AS object. Hierarchical AS set, just a heads up about this. Recommendation now is to include your AS number in the AS set. We've had a few famous incidents of AS Amazon actually not being Amazon. Or in this case, 2 weeks ago when I was at NANOG in Mongolia, AS Gemnet both exists in Mongolia. It's one of the big transit providers. And there's also an AS Gemnet in, what was the country again? CZ in the Czech Republic. Both AS Gemnet. And they were having terrible problems, as in the Mongolian ones, of trying to get routing to work properly. And we discovered if we went to some of the people they're having problems with, it was picking up the AS Gemnet on the right, not the one on the left. So the hierarchical AS set, so what was that? RFC 2622 is strongly recommended. In fact, in the APNIC region, it's now required. So if you're operating in the APNIC service region, you have to do the hierarchical AS set. So put your AS number, like in the example here. So AS, whatever the number is, colon, then the name of your AS set. So hopefully the rest of the world will try and do the same thing to get away from these collisions. So Maz, who did that presentation at SANOG 41 earlier this year, have a look at those slides. It explains the problem in a lot more detail than I can have time for here. So I've covered peering DB, IXPDB, and the Internet Routing Registry, just from the best practice point of view. So the final piece in 15 minutes are just configuration tips. So the iBGP and IGP reminder, right? We run the iBGP between the loopbacks, please. Not physical interfaces. Just because it lets us scale things in longer term. You may have two routers now. Yes, it'll run perfectly fine on the point-to-point link. What happens when you add a third? How are you going to do iBGP after that? So, I mean, networks I've built for years, we just build iBGP between the loopbacks. Make sure the IGP, remember, only OSPF or ISIs, not the rest in peace protocol. We carry the loopbacks, right? We carry those in the IGP. If you're using V6, you don't need any point-to-point links, link addresses. V4, you still have to. So, you know, the meta presentation this morning was quite nice because internally, it's all V6. There's no V4 internally. And so, you know, the speaker then talked about that big saving in the network. You know, you still got V4 externally, but internally it has that saving. So work hard on minimizing the prefixes carried in the IGP because it will converge faster and therefore scale better. What about the demarcation networks? Unnumbered interfaces, quite common. I mean, I was doing that way back in the 90s. UUNET were doing that also. Next up self and the iBGP neighbors, you don't have to carry the external point-to-point links around. Some operators carry the external point-to-point links, but in iBGP because they may need to monitor them in monitoring systems. You know, is your custom link down? Is your peer link down? Well, you need to know the point-to-point link. So you probably carry them in the iBGP instead, but please don't send them to the whole world, as some people are doing. Right, so next up self, limiting the AS path length. I wonder if I got the graph in this tutorial. Probably don't. Maybe I do, but this is fun. Let's say some BGP implementations have problems with long AS paths. So in the old days, it was a fun one. I'm sure some of you, probably 15 years ago, could remember the various crashes. If you sent AS path, 256 ASs in it, two big famous vendors, you could crash their routers. Boom, just like that. Because nobody actually checked. There was no bounds checking if it was longer than 255. So 256 overwrote something else in memory. So we're a bit more careful about this now. But even using AS path prepends, what do you think should the longest AS path be? I mean, Jeff this morning was saying 1.1 ASs. Yeah, because most people are accessing content which is just the local IX or close by. But on average today, the internet is 5 ASs deep. So why do we see AS paths that are 200, 250? We see those, lots of those. I mean, the largest AS path that I see that looks legit is about 16, 17, thereabouts, depending on the time of year. Why do we see some of these monster ones? Okay, the first one there, that I cherished that one from IPv6. You know, when in the days of the 6-bone, we had the tunneled V6 infrastructure before people were deploying native. I mean, that was a bug in a BGP implementation, but it still was a fabulously long AS path. But the second one was just weird. And look at it there. You see the little arrow if you know the Cisco CLI? The arrow means best path. So even with all those prepends, 100 prepends, it was still the best path. And it actually came up on the NANOG list. If you want to do the archaeology, I mean, it was somebody on the NANOG list because it was in my BGP report. And so somebody on the list actually wrote to the AS5404 and said, "Oi, what are you doing?" And they said, "Oh, no, that's not me." Well, you're the name in the AS, in the OTNAM object. "Oh, no, that's somebody else." Well, you replied from the email. Anyway, you go look it up. It was hilarious. And it hung around there for a few months and then it disappeared. But that was... that was one strange one. It was an old one. No, I don't have the picture. I should really put that graph in. I don't know what's happened in the last 10 years, but in the last 10 years, we see more and more of these massive prepends. I mean, I know why it is, and I'm not going to pick on the vendor in question, but it's one vendor is the entire cause of this. It's because people jump onto this kit, it's cheap, and they think it works the same way as all the mainstreams, but it doesn't. And so what happens is when they type in, the prepends they're doing, actually what this vendor is looking for is the number of times you prepend your own AS, not the ASs you're going to prepend. So they may say AS 20,000, but the implementation takes it, do 20,000 prepends. 20,000 modulo 256 gives the 200 whatever that we end up seeing in the BGP table. It's invariably caused by that. And just in the last 10 years, there are more and more incidents, and these are hanging around for weeks and months now, at least in the views that I have. And it's, we're fortunate these days that at least the vendors have fixed the code so that huge prepends don't crash routers. But certainly 15 years ago, it was a big deal. Anyway, maximum prefix tracking. Probably a good idea as well. If you're at an exchange point and you expect to get 20 prefixes from a neighbor, what happens when they suddenly send you 960,000? Well, you should be filtering, but if you're not filtering, what happens then? Suddenly all your traffic is going through some little provider you're peering with. So maximum prefix trafficking is probably a pretty good idea. Is a pretty good idea. So as I say there, configure a threshold. You'll see, if you have some places, maybe peering DB, exchange points, you'll see operators say, hey, please update your prefix limit to 20,000 prefixes. Well, when they say to do that, that's what you should be doing. Right? Because if they do end up having an internal configuration error that ends up sending you 900,000 prefixes, it's not going to break your network. Right? So you can do teardown, and it stays down until you bring it back up. You can have it automatically restart after so many minutes, whatever. There are many configuration options available. The BGP TTL hack. I mean, Dave Meyer talked about this, I don't know when, years ago. It was one of, my early NANOGs. Or GTSM, as the more official name is. Normally the TTL, 0 is you, 1 is the next router. But here what we're doing is we're sending a BGP update or BGP prefix or session with TTL set to 255. That means the neighbor is expecting the TTL to be 254. Because if you just use the normal TTL, anybody can jump on anywhere in the network and just send a crafted BGP packet, guessing the sequence number, and bust your BGP session. But if we set TTL to 255 on the origin, there's nothing this attacker can do. They can set 255, but they're not going to get the right TTL to try and affect your BGP session. So that was the intention of this. And it's kind of interesting just watching folks around the world. Some operators mandate the use of GTSM. The theory is, well, we have passwords in BGP sessions, but we'll also do this just to try and help protect. And of course, others say, well, when's my BGP session ever going to be attacked? Well, we could say the same about filters. Well, I've never leaked anything, so why do I need filters? Well, things can go wrong. So we need to try and protect our network as best we can. So Dave Meyer's presentation, NANOG 27, that was kind of where he proposed how this would all work, and then it got the RFC soon after that. What else? Templates. So, Team Cymru's has a good set of templates. I actually don't know where to find them anymore, because I was updating this and I got lost in that. There used to be teamcymru.org, but I don't know where it's gone. Maybe somebody from TC can update me. But they used to have all these great templates that all contributed by the community in the early 2000s about BGP configuration and a whole heap of configuration. It's just trying to get away from vendor defaults. The vendor defaults are not suitable for us. Right? What you need are the defaults that work for your network and make sure they're consistent across all the equipment that you have. So I've talked about all of these ones. iBGP between loopbacks, the next hop self, sending communities. Every vendor's different. You want to know all your communities across your iBGP, but Cisco will not send them by default. So make sure they're sent across the network, because if they're not, and you're using no export, means the no export vanishes the next router it goes to. Believe it or not, there's still BGP versions out there where you can set BGP version 3. Well, guess what? That's the classful version. So some people are still in their templates and older software hardwiring BGP to version 4. At least the modern implementations, you can't select the BGP version number. So that's probably important to try and do also. What else in iBGP? Passwords. Good idea to put those on the iBGP session. We're no longer in the early 2000s where the passwords were handled by cumbersome routines and control plane and could bring down the router. I mean, these days, a lot of people mandate passwords. And it's kind of interesting. You get a set of operators who mandate passwords. Another set of operators, don't you dare ever ask me for a password in the BGP session because I won't. And the other folks are like, yeah, if you want one, I'll put one on. If you don't want one, I don't care. So, what's the right thing to do? I mean, for any of the workshops that I've done, I've always put passwords in the BGP session, so at least the participants know how it's done and what's needed if they come across it. What else? Oh, eBGP now. I didn't mention it earlier, but there's still the BGP flap damping thing, which was a 1995 invention to deal with a 1995 problem, which went away in 1999. It's still there in the code. It's still in vendor documentation. If you build your network based on vendor documentation, you're going to end up in a very bad place. So please don't do BGP damping. Go read the RFC. Go read some of the updates. The routing working groups had to look at this. If you really want to break stuff, it's probably something you could implement, but please don't do it. It's served its time. It's 25 years out of date, in my humble opinion. Cisco soft reconfiguration. If you're doing ROV on Cisco routers, you need to do this unless you've got brand new modern code, which most people don't. Otherwise, Cisco soft reconfiguration turns off route refresh. You can't get access to route refresh. So think about that before you do it. So again, some of the workshops I do, which are using a virtualized iOS, some of the participants automatically turn it on. And I say, well, why have you disabled route refresh? Oh, is that what it does? I thought soft reconfiguration was route refresh. No, it is not. It's something that predates it. Stripping up private ASs, please do that. We shouldn't be seeing anything apart from public ASs in the global routing table. Have a look at RouteViews if you're bored. I look at the global table probably too much for my own good, and it's just amazing some of the stuff in there. Filters. Filter your eBGP sessions, RFC 8212, please. Filter in, filter out. Very, very important. All eBGP sessions, whether it's private peer, public peer, transit, customers, please filter. Passwords I mentioned before. For iBGP, do it for eBGP also. Maximum prefix tracking. Maximum AS path length. What's the longest AS path you expect? I mean, 20, 30 max? Why do you want to get these 200, 250 times prepends? What else? Logging, so the neighbor state change, what's happening there. The BGP administrative distance. I haven't mentioned admin distance because that covers all the different routing protocols. Believe it or not, each vendor has different administrative distances for different routing protocols. And again, in a mixed vendor environment, you're going to end up in knots if you don't harmonize them. So keep an eye on that too. Got to mention manners. I mean, even though we were doing all the best practices for many years before, giving it a nice name like manners means people, I don't know, do they pay attention more now? I hope they do. But there's more on manners.org website, but the 4 points are prevent propagation of incorrect routing information, filters, please, everybody, filter, filter, filter. Prevent traffic with spoofed source addresses, BCP 38, it's been around since, when did Danny McPherson do that? 1997, something like that. But I mentioned BCP 38 to a lot of newcomers to the industry, and they go, what's that? And I mentioned unicast reverse path forwarding, and it's even more blank stares. So it's been around for a very long time. So we need to be doing this so we don't get traffic with spoofed source addresses going out there. Facilitate communication between network operators. Not everybody will go to a NOG. I mean, NANOG is big. Most countries around the world have their own NOGs, but not everybody goes to them. A lot of people don't see the value of sending the technical staff to NOGs. So put information in peering DB, please, or in the route objects, AS objects, internet registries, the regional registries, the internet routing registry. Put information in there so you're contactable, so somebody can get hold of you. And knock-to-knock communication doesn't mean speak to somebody's customer support, because they go through the 25 questions, have you turned it off and on again? You don't want that. You want to speak to somebody who knows how the network works. Route origin authorization using RPKI. I mean, Aaron will be talking enough about that this week anyway. Please do that. What else? Yeah, these are the detail ones. I won't bother with that. And that's pretty much it. So summary of all this, the configuration templates, standardize your configuration, the standard tricks, the best practices, the Manos fundamentals. Ultimately, it's all about scalability. Keep things nice and simple, nice, straightforward to build yourself a scalable network. And that is it.